In the last section, we came up with a very efficient way of finding the definite integral. That was using the fundamental theorem of calculus. So in this section, we're going to talk about the indefinite integral. So first, let's take a look at the definite. So the definite integral said the integral from a to b of f of x dx is equal to, and if you recall the fundamental theorem of calculus, we had proven that the integral is related to the antiderivative. How is it related to the antiderivative? Well, you find the antiderivative of little f, you evaluate it at the upper limit, minus you take the antiderivative and you evaluate it at the lower limit. Okay, so when you do that, you are finding the area underneath the curve between those two values. So what you get back is a number. This is going to be a number answer. All right? So that's why we call it a definite integral. There is a definite answer. Now let's talk about what an indefinite integral is. So an indefinite integral, let me show you what it looks like. Integral, little f of x dx is equal to big F of x plus c. It's indefinite because the c is arbitrary. It's an arbitrary constant. If we had an initial condition, we could find a exact f of x for it. Okay? Definite, we have these limits, we get our actual answer, okay? So an indefinite integral, all it's telling you to do is find the antiderivative. We did this in section 4.9. So we just give it a different definition. The antiderivative, the indefinite integral of f of x is the antiderivative, and you add on your constant. So the difference between the two, you're going to get a number answer for the definite integral. The indefinite integral, you're going to get a function back. Okay? So let's go ahead and do some examples. Like I said, you've seen these similar examples before in section 4.9, the antiderivative section. So it says find the general indefinite integral. So integral sign 5 plus 2/3 x squared plus 3/4 x cubed dx. There's our first example. So all this is saying is anti-differentiate each term, find the antiderivative, and then put my constant at the end, add my last constant. So all of these are power rules, okay? So to undo the power rule, this 5 here, you could think of it as 5x to the 0 power. You go up 1 power, so x to the first power. And then I take the coefficient and I divide by that power. So divide by 1. So you're just going to be left with 5x to the first. So next term, go up 1 power, it's x squared. So it's going to be x cubed. Remember, we're undoing the power rule, going backwards. So it's going to be 2/3 divided by, now I divide by this power. So if you simplify this, you get plus 2 or 9 x cubed. Now this term here, well, I'm going to go up 1 power, it's a cube, so put a 4 there, going up 1 power. And then it's 3/4 divided by, and you divide by this power, 4. So this simplifies to 3/16, x to the 4th. Now you can't forget plus c. There you go. there is the indefinite integral of this function here. All we did was find the antiderivative. Nothing different from section 4.9. Let's look at the next example. One plus r divided by r. I'm gonna square it. And it's integral dr. So that tells us what variable we're integrating with respect to. Okay? So we don't know how to integrate this. So we can't integrate this how it is right now. However, we do know how to square stuff. So let's go ahead and square it. Now before I square it, you could square this right away. What I'm going to do is I'm going to split up this this addition right here. So I'm going to rewrite this as the integral of 1 over r plus 1 squared dr. See, now what that did there was here I'm going to square the numerator. I'm going to have to distribute it out. I'm going to square the denominator. Squaring the denominator is pretty easy. But then I'm going to have to divide everything by the denominator and do a little bit more work. Here, when I split up this addition, now when I square it, it takes away having to do that division, okay? Because they're all separated. Here, it's a quotient, but here, it's only a sum. So when I square this out, integral, I'm going to give you the answer real quick. 1 over r squared plus 2 over r plus 1 dr. So yeah, if you were to square this, you're going to get this. So I'm going to come over here, equals the integral. I'm going to rewrite these as r to the negative second power plus 2r to the negative first power plus, now 1, I could write it as 1r to the 0. Now, something to keep in mind, you don't have to keep writing like the constants with the r to the 0 power if you don't want. Just know the integral of a constant is just whatever that variable is times by the number in front of it, okay? So if this was a 5, when we integrate this, it's just going to be 5r. Or if it's 1 right now, we're going to integrate, it's just going to be r. So now let's go ahead and find the integral of this, the indefinite integral. This one, go up 1 power, so r to the negative first. There's a 1 in front of here, 1 divided by, I got to divide by the power up there, so negative 1. Plus 2, do we go up 1 power and then divide by it? We do not do that here, okay? If we go up 1 power, we're going to have r to the 0. 2 divided by, we got to divide by the power. 2 divided by 0. That should send off alarms saying, hey, I did something wrong. I got a division by 0. This right here is the special case. 1 over r, or any number over r, or r to the negative first power, the integral of that is ln. ln, absolute value of r. And then integral of just the constant plus r. And then I tack on the plus c. Alright, so let's see. Let me erase some things. Because we finally got an answer. Let me rewrite my answer. Right here. Negative, that's a 1. I'm going to put the r on the bottom. Negative 1 over r plus 2 ln absolute value of r plus r plus c. Don't forget your plus c. It's very important. Forget your plus c. I'm going to take a half point off. So all we did was find the antiderivative using the differentiation rules that we have available to us, okay? We don't know how to differentiate this, so what we just needed to do was rewrite it algebraically. We squared everything out, okay? Upon doing that, it gave us everything with powers that we could undo the power rule or undo a log function. The next example I have is going to require us to do a little bit of trig. It's the integral of 2 plus tangent squared of, what's our variable here, x. X dx. Now, if you recall what I just said about constants, when we integrate this 2, the 2 is just going to integrate to a 2x. However, tangent squared, we don't know how to integrate tangent squared. If you look back on the table of antiderivatives that I gave you, tangent squared is not on there, okay? So we may have to do something else to integrate it. Instead, we're going to algebraically manipulate this, okay? So here's our starting spot. We're going to get something over here that we can integrate. I'm going to do the work down here. I'm going to pull this piece off, 2 plus tangent squared of x, and I'm going to rewrite it. 2 plus sine squared x over cosine squared x. Let's go ahead and find a least common denominator. Well, this is over 1. So the least common denominator is cosine squared. So we got a cosine squared of x over, well, this is missing the least common denominator, so I got to multiply this 2 by this cosine squared of x. 2 cosine squared of x plus sine squared of x. All right, I'm going to do one more thing. I'm going to break up this right here. I'm going to write it as cosine squared x plus cosine squared x. Because now, this entire numerator, I have a plus sine squared x. What is cosine squared plus sine squared? It is equal to 1. So this entire numerator, we still got that cosine squared. So it's cosine squared x plus 1 divided by cosine squared x. And now what I'm going to do is I'm going to break up this numerator. I get cosine squared x divided by cosine squared x plus 1 over cosine squared x. Well, cosine squared divided by cosine squared is 1. Plus 1 plus cosine squared of x. Well, that's just secant squared of x. So now we have it in a lot better form. See, another way you could have got there, a little bit faster way, use the identity for tangent squared. Tangent squared is equal to secant negative 1, secant squared minus 1. Yeah, secant squared minus 1. If you put secant squared minus 1 here, 2 minus 1 is 1, then you got your secant squared. Alright, so we want to integrate this. Just find the antiderivative. The antiderivative of 1 with respect to x is just x. Plus the integral of secant squared x, find the antiderivative of secant squared, well, that's tangent x. Don't forget your constant, plus c.